Hello everyone, welcome to this class. Today we will be solving an exercise about the heating curves. And actually a heating curve is a curve as this one you can see here, in which we will be increasing the temperature of a compound or a material, and we will be seeing what are the changes of state which are happening. So here the diagram shows a heating curve of or for a sample of compound X. As you see here, that we will be starting heating this material under the temperature of 50 degrees Celsius. By doing this, the temperature will increase and this compound will be starting changing state. As you can see here, we have two plateaus, okay, which means from B to C and from D to E. And actually, as we studied in the course, that in those plateaus, here we can find the change of state, okay, and we have two plateaus here, which means that the first one from low temperatures or in low temperatures will be actually the plateau for the melting, which means the physical change from solid into liquid. And the second one will be the plateau for the physical change from liquid into gas. So let's see the questions. Is X a solid, a liquid, or a gas at room temperature? So as you can see here, 20 degrees Celsius is somewhere in here. Okay, let's say that here is 20 degrees Celsius in this place here. So this means that we need to find out physical state of our material in this region here, which means between C and D. Actually, while heating our material, it will be changing state from solid into liquid. And this plateau here is referring to the melting. Okay, in the plateau we will be having melting, which means that in B, on the point B, we will be having or we will be seeing the first drop of the liquid which is forming here, and on C we will be seeing the last piece of the solid which remain in the let's say, for example, a beaker, if we are heating our compound in a beaker. Okay, so between B and C it's the melting process. So this means that in this place here, which is in 20 degrees Celsius, the physical state of our compound X is liquid. Okay, so is X a solid, a liquid, or a gas at room temperature? So here the answer is at room temperature, compound X or X is liquid. Okay, let's see now. Next question. Write an equation for the equilibrium which exists in region BC. As I told you, in BC there will be an equilibrium between what? Between the solid, which is here. Here we have the solid, and the liquid, which is in this region. Okay, so the answer for this question is X in solid state, which is in equilibrium, with X in the liquid state. Question C, name the change of state which occurs in region DE, which means here. As I told you, we will be having two plateaus. The first one is for the melting, and the second one will be for the change of state from liquid into gas, into the gaseous state. So on point D, we will be having the first gas, or let's say the first bubbles of gas which are forming. And in E, we will be having the last drops of the liquid which remains in the beaker. So here, this is boiling. Boiling is actually happening in DE. So name the change of state which occurs in region DE. It's the change, here we can write that the change of state in region DE is from liquid to gas. okay, is from liquid to gas. Good. In question D, the question here is, explain how the curve shows that a pure sample of compound X was used. So in the curve here, you can see that we have horizontal plateaus or horizontal regions, and actually this is what shows that our material is pure. Okay, so here we can write that as an answer: horizontal plateaus are present in the curve. Okay, so if the compound was not pure, actually we will be having here a slope line, which means we will see on the curve something which is like this, which is not horizontal. Okay, and actually this is due to the fact that if we have an impure material, this means that it will be composed from different compounds or different materials, and each one of them will be having a specific melting point. Okay, so we will be having a slope line if the material is not pure, and if it is pure, we will be seeing the horizontal plateaus in our heating curve, or the same as if we are dealing with a cooling curve. So that's all about this exercise, and thank you for watching.